starting today. This is a series of 5 courses all on how to model some features in EnergyPro. We're going to start with domestic hot water, and every other Wednesday we will continue on with this tech topic series. All of the courses in this series are eligible for BPI continuing education units, as well as continuing education credits for the multifamily upgrade program, which are required to maintain your eligibility with the program. In addition to these 5 tech topics, we're hosting a series of principles of building science topics. We're going to start with one topic that's a little bit outside the series. That's on May 13th. TRC will be hosting that class along with Partner Energy, and we're going to go over common modeling mistakes that we're seeing during assessment review and try and give you all a peek behind the curtain as to what happens during assessment review to hopefully speed up the process for you and for us. After the initial course, we're going to launch into the Principles of Building Science training series, which is going to start with an overview about building science and continue into building envelope, HVAC and pressure, HVAC and domestic hot water, lighting and electrical, and a building analyst assessment. This series of courses is going to guide you through a BPI Principles of Building Science curriculum. So if you're attentive and if you do homework outside of the 1.5-hour webinars, there is an opportunity to take the BPI Building Analyst course and field exam and field assessment at the end of this series. So please invite your staff members, maybe some other people in your organization that are interested in brushing up on their skills. And at the end of that series, there will be a diagnostic training day. Training will be available probably at the Stockton Energy Center, where we will get some hands-on experience doing diagnostic testing and diagnostic training. And we're also going to open up an opportunity to take or challenge the BPI Building Analyst test at the end of this series. This series of courses, all upcoming courses, except for the assessment review multifamily upgrade training course, are eligible for continuing education credits. So at the end of each course, please email your BPI number for credit, and we will send out reminders about that information moving forward. So I'm going to now hand it over to Kyle Brumfitt, who's going to start off our tech topic series on EnergyPro modeling and domestic hot water. If at any time during this webinar you have a question, please feel free to raise your hand or type a message to us in chat, and Kyle will take a couple breaks throughout the course of his presentation and address your questions. Thank you all for attending, and I hope you enjoy.
All right, thank you, Mike. Hello everyone, my name is Kyle Brumfitt. I'm here to discuss the domestic hot water EnergyPro modeling. So I'll be doing all the webinars for the EnergyPro modeling series. So I hope I get to, I hope you guys can listen in every other Wednesday, noon, and then we'll get started. So I just want to make sure it's very clear to everybody that there is a modeling guideline that PG&E has put out for the program. They require that all partners follow the multifamily retrofit energy modeling guidelines. You can contact your program administrator, Mike, for the latest copy. So please use those when you're modeling for the program. The project we're going to be discussing today is it's 2 buildings located in San Francisco, and they're roughly 68,000 square feet. It's a multifamily property and a total of 48 units. And we'll be in climate zone 3. We have on site, we had 2 central domestic hot water boilers, provide both radiant heating and domestic hot water. So the idea for this webinar is to how do we model those domestic hot water units according to the load need for the 2 buildings. So it's one system serving 2 buildings. You would have to model both buildings separately, and you'd have to split up that domestic hot water usage per building. First thing I want to talk about is the data collection forms. So each partner shall have a way to document what is found on site. Project field notes are translated into what we call something called a report general data. This is what we have here in-house, partner energy that we use to take our field notes, and it translates into report general data. It's very important to be able to revert back to all your field notes and keep them on file if there's any questions at hand. So, we have basic project description, lighting, HVAC in common areas, HVAC in the units, appliance unit in common area, domestic hot water in common area. And so there's quite a bit of information everybody knows that we need to collect on site, and it's very important that we can keep that information and be able to give it back to whoever's reviewing our information, our models. They find out where we got this. So if you're like me, field notes, writing field notes down, it might be hard to go back and read those later on. So it's always good practice to put them into something that's legible for future use. So here we have our domestic hot water serving those residential units. So we can put that information into our report general data. Now, report general data is, you can build your own how you want it to use, but obviously you want to make sure you're collecting all the information you're collecting on site is translated into that report general data. So that will be the first step in your modeling exercises. So 2 main ways to finding your system. So you get out on site and you get model numbers and photos, manufacturers, and all that good stuff from the nameplates. First step should always be to go to the HRI Directory. So if you're familiar with the HRI Directory, it looks something similar or something like this. This is exactly where it goes. And you have broken down from residential and commercial. And they have a lot of different products that they certify. So we're basically looking at the boiler or your domestic or your water heating for residential, or pending the model number and make you might see out on site. It could be a commercial grade boiler or water heater. So if you don't see it in the residential one, then obviously go check your commercial. And make sure you can find that information. Now, these are really the modeling inputs you put into EnergyPro. These really should all be third-party rated inputs. The CEC really approves the HRI Directory and then their own CEC appliance database. So those are the 2 big resources that you're going to want to bookmark for future use. You have on the CEC appliance database, you have a quick search that you can do by category, manufacturer, brand, or model number. And then you have the more advanced search that, when you start selecting whether, it's large or small water heaters, you can kind of go, you see how it, it opens up and you have more of a selection to choose from. My quick tip is to use the quick search first, go in by model number, select the model number you need, or type in the model number you're looking for, and hit go, and then from there it'll come up at the bottom, and you can look further in on the advanced to get what you need. So for instance, we have the SUF 100, 199. So it sees how it brings up a bunch of different model numbers. You can click on one, it goes, and it'll tell you kind of where that's at. So you don't have the details you need right here, but you know that the model number exists on their database, and then you have your type, manufacturer, brand, and model. That those categories translate back to your advanced search, and then you go for your type, your category, water heater, large, manufacturer, and so on. So that's kind of the way that I work with the CEC appliance database. With the HRI database, it can, if you try to put too much information in that, it can get you won't be able to find what you're looking for. So start off with just the brand or the manufacturer, and you can search through that way. It's going on here. So we have for domestic hot water, I wanted to make sure we talked about the standby loss and energy factors before we get into the model itself. So standby loss and energy factor is important to know the difference between and what the BTU per hour threshold is that would have a manufacturer's or third-party certified rating on. So standby loss is the percentage of heat or energy loss per hour of operation due to radiation from the storage tank. This is an additional input for large capacity boilers. So that is greater than 75,000 BTUs per hour. You go out on site and you find something that's over 75,000 BTUs per hour, you know that you're going to need to find a standby loss or have a standby loss for that system to plug in at EnergyPro. And we'll be talking about that further in the webinar. Energy factor is a measure for smaller capacity boilers, and this includes a standby loss calculation already in it. So you won't have to put a separate standby loss calculation. The energy factor has that inside their performance criteria for rating a product. HRI rated large storage water heaters, we also list the standby loss. However, this is not the standby loss you use in EnergyPro. The percent metric listed on the HRI differs from the standby loss listed as a BTU. So I'll explain that as we get into. I'll show you what an HRI certificate looks like and where that's all, where that's coming from in a minute here. I just wanted to make sure that there's a difference, and the standby loss that may be listed could be a BTU listing, and you don't want to plug that in. You want a percentage metric loss that you get to put in. So to calculate your standby loss, consult the HRI Directory as we talked about. That's the first step for pretty much any kind of equipment you're putting into an energy model, but we're talking here about domestic hot water, so you want to make sure you can pull up, this is what a certificate looks like from the HRI website, and if you see here, it gives you a standby loss in BTU, so you need to convert that into a percentage loss for EnergyPro, and I'll show that in a second. But that's a certificate. That's the type of certificate you're looking for. And basically, to convert that percentage loss, you want to simply divide the standby loss BTU by the input of that rated system. So, for example, if there was a system that had if this was your BTU loss, this is your total BTU. Your percentage into EnergyPro would be this number right here. So in your report general data, you should probably have a section there that would calculate that and show you, what that's going to be. I'm going to switch over to EnergyPro real quick. I want to show you the building that we're talking about here and get you into the domestic hot water tabs. So we have two buildings that were built because obviously it was two buildings on site that we're looking at, and we need to build them both separately. These both buildings share, as I said earlier, share that's some domestic hot water that provides both radiant heating and domestic hot water. So we have domestic hot water tab under your plant. You're going to go ahead and get into that guy. Click in there, and so this is where all your inputs are going to be going for your specific system. So the next slide I had up was talking about combined hydronic piping. So this is for your either your radiant heaters or basically your wet HVAC, hydronic piping that's going to be used for heating that space. When we're talking about pipe length for the hydronic piping, you need to estimate your pipe length. The pipe length that they're looking for in EnergyPro is the pipe length that is in unconditioned spaces. So total length of pipe in unconditioned space for all boilers that are part of this hydronic space heating system. This input is used only in residential projects and should be the total length for the system, not per building. So you're going to then have to take your plans or take your sketch that you did and try to estimate the best you can what that total pipe length, linear footage, is in those unconditioned spaces. And you're going to pop that number into this pipe length section here. It's always a good practice for inputs. Basically, before you go on site, you're like, what do I need to collect, right? So, you want to really be specific with what you're looking for, and a good guidepost to have to use is, what do you need to put into EnergyPro to get the result you're looking for? So, if you don't have if you're not normally looking for pipe diameter when you get to a hydronic system, maybe it's an added field that you put into your report, your field notes and your report journal data. You want to document that. If you see any insulation or thickness of that insulation, you want to document that as well. So combined hydronic piping, the big takeaway from that is it's the pipe length in unconditioned space. So we have a domestic hot water serving multiple buildings. This is exactly what we are looking at here. So when you have a central system serving multiple buildings, you have to split up the domestic hot water usage accordingly. This is what I spoke about before. This is the main topic of our, or one of the main topics of our domestic hot water discussion. So the splitting up the splitting up of the system should be based on the units in each building. And there is a domestic hot water split calculator that TRC can provide. So contact your administrator for a copy of that. But I will show you what it looks like here. So it's fairly simple to use, but it is very important. It does have a big impact on the way the results will be for your buildings. Basically, you're up here in the top, you're putting in what your total system capacity is. So we had two boilers or domestic hot water units and 2 storage tanks go along with it. So we're kind of doubling up all the BTUs up here because that's the one system that's serving the 2 buildings. And then in the blue tabs is everything you fill in, as it says over here, and then the green is all stuff that's calculated for you. So we have 2 buildings. The first building is 12 units. The second building has 34 units. And it splits it up accordingly to all the information you have in here. So length of pipe outside, length of pipe underground, your horsepower. It's important to remember is your horsepower then is broken up as well. Adjusted gallons, adjusted BTU, and adjusted horsepower. Now, the adjusted BTU, I want to be kind of go back to what I was saying before about greater than 75,000 BTUs or less than 75,000 BTUs. You want to, if you do this split up, and say your adjusted BTU turns out to be less than 75,000 BTUs, well, you want to make sure that that thing is over 75,000. So if it's right around that number, you want to, or if it's below 75,000 BTUs, you want to make sure it's 75,001 BTUs. And the reason is because you're then going to have the option to put in that standby loss calculation. That's very important. Otherwise, it's going to look at it as a small domestic hot water system, as shown before, and you're going to be looking at an energy factor, and it's not the same as your standby loss calculation. So that's a very important thing to remember, and you want to make note of that in your modeling, assumptions, or however you document your, your inputs for modeling. You might want to say that this was an adjusted factor. We put it in there as 75,001, so we can ensure we have the correct standby loss calculation. Mike, I think this might be a good time to maybe pause and see if there's any questions from what we discussed so far. You maybe can ask them.
Sure. I've got a couple questions that I've tried to answer by chat, but hopefully we can just bring it up for everybody to be on the same page. So you spoke a little bit about the HRI number usually gives a standby loss number in percent and not in BTU per hour. So the question was, how do you convert this number? So if you could just touch on that one more time through.
Sure. So it's actually, if you see here, the standby loss is provided in BTU. I think what I was saying is that you don't want to put that standby loss number into EnergyPro as just, a standby loss BTU number. You want to put it in as a percent. So does that clear up that question? You're going to be getting a BTU from the certificate. You don't want to put the BTU within here. You want to put a percentage.
And this standby loss really has a large impact on the performance of the domestic hot water system. So make sure you calculate that correctly. If you have more questions, go ahead and ask them, and we can circle back around. The only other question that we have right now is, what if we have a tankless water heater that is greater than 75,000 BTUs per hour? Is that rated on an energy factor or the efficiency and standby loss factor basis?
Well, I guess for the larger multifamily, if you have a tankless type system, I believe it's going to be still a standby loss because there is a small tank. I mean, there's a little bit of water that's in there. I'd have to go back and I'd have to look it up in the HRI and just look for that model number, and whether it gives you a standby loss or energy factor. I'd have to look at it case by case. I'm not exactly sure what they do for all of the large tankless. If you have a tankless water heater, most likely going to have some sort of tank associated to it as a storage, kind of a holding tank. So there'll be losses between that, but I'd have to look at it by model number and check it out myself. So to answer the question, just go to the HRI Directory, see what they give you, and plug it in like that. They're most likely going to give you a standby loss if it's over 75,000 BTUs, and give you an energy factor if it's less than.
Okay, and for now, let's just move on, and there's more questions coming in that we'll catch on the next pause.
Okay, sounds good. And just to reiterate the fact about the standby loss calculation, you can find that in the multifamily energy modeling guidelines. So once you get a copy of that, you'll be able to keep that on hand. And I talked about it in the slides here. So, all right. So we're going back into, we're going to talk about multifamily central systems and how to plug that into the EnergyPro. You know, I'm going back and forth in the model, but I want to show you where these things are in EnergyPro as well as kind of follow along in the slide. So in EnergyPro, you plug in your system. This is the split boiler that I got from my domestic hot water split Excel sheet. Put that information in correctly for the building type, and then it's more than 6 units that it's serving, so we need to select the multifamily central system checkbox there. And then we get into the different types of pump controls and other things like that. So let's talk about pump control. You know, temperature control is the most common control you will see out there in the field. If you don't see a control, you can always suggest a temperature control because it is, you know, it's a very effective and low-cost kind of control that you can put onto a system. Other ones may be timer, demand, or timer and temp. Just keep that in mind. Temperature is a good one to ask for, or not to ask for, to recommend. Pump multiplier, you know, obviously it's pretty self-explanatory. However many pumps you see out there, you want to put that in as a pump multiplier. Now, just keep in mind that if you see multiple, different size pump horsepowers, you don't want to multiply out that pump. You know, there's 2 different horsepower. One's half horsepower, one's 3/4 horsepower. That's 2 different pumps altogether. So it's not a pump multiplier. This is talking about similar or like type pumps. And the design horsepower. So design horsepower or design power is different than like a rated horsepower. So your rated horsepower is what the pump is rated as. So it's it's a half horsepower. It can run up to a half horsepower, and that's not really how that pump is going to function all the time. So what is called on the industry is a brake horsepower, and so you wanted to make sure you can find a brake horsepower. Brake horsepowers are typically listed in the manufacturer cut sheets. So it'll be a rated horsepower and then a brake horsepower. The other thing that you might see out there, sometimes pump energy is expressed in kilowatts. So you want to divide the kilowatts by 0.746 to convert that into brake horsepower. So 746 watts into a horsepower. So that's why you have that. That is the equation, and that is in the slides here, which we might, so I can show you if you want to write that number down. If your pump energy is expressed in a kilowatt, divide that kilowatts by 0.746, and then convert it into brake horsepower. Brake horsepower is what that pump's really going to be running at when in operation. If you put in horsepower, you're overestimating your your pump energy. So we're talking about piping now. So piping, this is a distance in linear feet for piping, outside, underground, or in plenum. So this is different than the combined hydronic piping. That's why I wanted to make 2 separate slides for it. Your combined hydronic is unconditioned space, if you all remember. Piping for domestic hot water is all piping, and you have these 3 different categories that you can choose from, and you want to calculate the linear footage for all applicable categories. Calculating that pipe length, these are existing buildings that, obviously might be very hard to see where those pipes are going. You have to really use common sense in this kind of thing where my typical rule of thumb is, depending on where the domestic hot water is located, try to maybe just draw out, how that would be piped. Use that as your file, you keep it on file, saying this is how I distinguished what the piping would be. For this building, the domestic hot water system was located up in this building over here on the right, on the roof. It was a 3-story building, so you basically take, obviously the domestic hot water is going to each of the dwelling units, right? So I typically just take the length of the building and multiply that by how many stories you have, and then I add a supply run from the top of the building down to the bottom and back up. So that's kind of rule of thumb of how I get my pipe length. And then similarly, for this building, it was then piped, underground. So I had that component to calculate and put in, and it went over to this second building over here. So, if you have a site plan, use it. If you don't, you may paste it off or get some kind of rolling measuring stick to calculate that linear footage. A lot of times you might be able to see where that pipe is actually leaving the building, going underground, and then going into the other building. So you can kind of go from point A to point B that way. So you have your underground linear footage, and then you have, again, your piping in conditioned space, just your piping outside, in plenum, or underground. So we have the in plenum, basically like in building shafts, that kind of stuff. You want to do the same calculation over here. Take the length of the building, take how many floors that building has, and then the height of the building or wherever the domestic hot water is located. If it's got to go all the way around the building. So you want to just make sure you're calculating that linear footage accurately. It does make a difference in your modeling. So you want to make sure you're not overestimating, and then obviously not underestimating. So that's why I use this is my good rule of thumb, kind of common sense approach to calculating pipe length. Okay, so now we're going to assign the system to the residents. So you've done your calculation of linear footage. You got your pump information in there. You visually verify that there's no pipe insulation on this existing property. And so we have all of our residential units lined up out here. Now, I build my energy modeling on unit by unit because I'd use it for a lot of different avenues. It's not required by the program to do it that way. Mike wanted me to make sure that was clear that you don't need to do a unit by unit. Whole building approach is just fine. However, here at Partner Energy, what I do, I use modeling for a lot of different avenues, and it's easier for me just to do it unit by unit so I can use the same model for other things. So just imagine that this is just a whole building system here. But you're going to go to the residential tab, and you're going to now go to the hydronic space heating box, and you're going to be just telling that system, HVAC system, that the domestic hot water boiler is providing the heat. So in this case, it was a radiant system hydronic baseboard. So you have your existing hydronic baseboard in here, and this needs to get its heat source from somewhere, so that's where you're telling it over here on the residential tab, hydronic space heating. The domestic hot water boiler is providing space heating. Another very important thing to remember for domestic hot water calculations is to ensure you have the correct occupancy count for your residential side of things down here. Number of bedrooms and kitchens does make a large effect onto the energy modeling. So you want to make sure your number of bedrooms and number of kitchens is accurate. And also, you'll get an error. So if you've done this wrong, the software will tell you. But the next thing is to make sure that you have the right number of dwelling units up here. And basically, the way that the software looks at it is you're going to have one kitchen for each dwelling unit. So if you have more than 12 kitchens in here, add it all the way up. Or if you do the whole building approach, you might just have one floor by floor, or however you set up your model, following the multifamily modeling guidelines. Make sure that the kitchens and bedrooms add up. It's going to make a big difference. Okay, so now our system has been associated to the indoor HVAC. This could have any wet HVAC. Really is you're just trying to tell the software where this heat source is coming from, and this is exactly where you're going to do that. So with that, guys, I just talked to you about going to the room level and doing the building tree, make sure the occupant count is correct, and that domestic hot water usage is calculated based on the number of bedrooms and kitchens within EnergyPro, so that's why it's very important that you want to have that right. So with that, guys, we've kind of gone through we've done through everything you would need to know for inputting domestic hot water, showing you how you split up that domestic hot water, showing you how you find your performance factors for your domestic hot water system, showing you how you would calculate different pipe lengths, and that closes out the webinar for domestic hot water inputs for EnergyPro. So I can open it back up to questions, Mike, and see if we can answer any of those.
Great. Yeah, thanks, Kyle. And there's some questions that I'm going to go through that we tried to answer in chat, but I just want to make sure everybody's on the same page. And some of these I can just answer as from the program, and some I'll hand off to you, Kyle. So the domestic hot water energy calculation spreadsheet that Kyle showed is based off of the dwelling units in the multifamily buildings. This is an approximation for the square footage of the buildings, and we're using this to provide an easy way for you to split up a domestic hot water system across multiple buildings. There are other ways to implement this process, and we're trying to balance speed and ease with accuracy and precision. So this is the way that the program is requesting that you implement this process for now, and we are, of course, open to suggestions and feedback about that process. But the way we're basing the domestic hot water performance is roughly approximately based on the number of units in each building if there is a central system serving multiple buildings. There's a question about...
Sorry, Mike, just to touch on that, if I put the standby loss calculation at the bottom of that sheet, so it might be something good for other partners to do if they feel like they need the need to keep that standby loss calculation close by.
Thanks. Okay, another question was, what happens when the existing water heater is so old that it's not listed in the CEC or HRI directories? There are tables that are available in Title 24 that are called the vintage tables. They're also sometimes referred to as default values. They're also referenced in our energy modeling guidelines and the contractor and rater handbook of the multifamily upgrade program. We provide for you the energy factor as well as the assumed efficiencies of old systems by year. So if there's a system that was installed in 1962, we can give you a vintage table or default value for the performance of that system. If you have a question about what the right value is, please contact me, Mike Maroney. The next question is, how would you estimate, and I'll throw this one to you, Kyle, how do you estimate pipe diameter for a large system with several pipe sizes in the distribution system?
It's a good question. You know, I think it really gets down to the pipe diameter closer to the end and it being where it's serving. I would be more concerned about that one than the pipe diameter at the, let's say, beginning of the run, because obviously if you're trying to push a lot of water through, you know, diameters are going to change. So look for the pipe diameter that is going into the unit serving that space. Does that make sense?
Yeah, and I would just, yep, that makes sense to me, and I would just echo, the more information that you can find, the better. So if you happen to have plans, or if you happen to be able to get into some of the inaccessible spaces in the building, you can do a weighted average of the pipe diameter. But we understand that retrofit projects are not perfect. You don't have perfect access to all the information. So use your best judgment, and if you have any questions, even when you're on site, feel free to give me or any one of us here at the program a call or by email, and we'll try and get back to you as quickly as possible. There's a question about standby loss as a percentage of what? Just divide the BTUs per hour by 100, or what do we do with these numbers? So there's a couple different terms being thrown around here related to standby loss. The best guidance that you can find is in our energy modeling guidelines, or as I keep referring to, you can always give us a call here at the program. The standby loss is sometimes presented as a percentage. This is a percentage of the total input rating of the system. The standby loss that EnergyPro uses, that we're using for the program, is technically a unitless number, so you can think of it as a percentage. It's a convoluted topic, and it's hard to explain without having you know, numbers to look at in front of us. But the correct standby loss number is on the order of 0.00 something is usually the range of the standby losses that we're dealing with the water heating systems that we're working on. So if you have a question, yep, and Kyle's showing you there what his number was. So if you've got a number in that range, it's probably accurate. Feel free to send it over to us for review. If you have a boiler with a tank, the boiler system is going to be rated on the recovery efficiency that's given by the nameplate or by the HRI Directory, and the standby loss is for the tank. That's accurate, and that kind of logically follows where you're generating all of the heat in the boiler system, so that's going to have an efficiency of generation, or an efficiency of how quickly or how efficiently the gas energy is converted into heat within the water. When the hot water is just sitting in a storage tank, it's going to be releasing some of that heat just based on how well it's insulated and what the temperature is of the space around it. So you can think about it in a system that has a boiler and a tank separate from one another. Those are the two measures of efficiency we're looking at. The standby loss controls or dictates the efficiency of the tank, and the recovery efficiency or the thermal efficiency dictates the performance of the boiler.
And there's the CEC has calculations on how to calculate separate storage tanks standby loss, and you can look at those and refer to those, but I would also run that through the program administrators. If you have that scenario, make sure that they're on board with how you're calculating that standby loss.
Thanks. Yep. Next question is, how do you simulate primary and secondary pumps? primary pump may be on constant volume, and a secondary pump may be a larger pump that is a variable frequency drive pump. How do you simulate this type of system? I've started to see this more frequently in newer or new retrofit boiler rooms where you've got two pumps on two skids sitting next to each other on the ground. I usually only see this, though, in larger buildings, and that's frankly where you're going to get a lot more response from the improvement of these pumps in terms of the non-residential performance versus the residential performance modules of EnergyPro. For the size and scale of buildings that we deal with, the nuances of VFD and the performance of high-efficiency pumps are not as easy to model and implement. So if you have a project that you're working on that's dealing with primary and secondary pumps of different sizes and control strategies, go ahead and just talk to us and we'll deal with this on a case-by-case basis. If it becomes a more common issue, we will provide some guidance to everybody about what to do in these scenarios.
Yeah, we will be talking about that kind of information on the cooling towers, chillers, central plants. That's like Mike said, in the non-res kind of calculations on how to do it. That's where you can take an advantage of this primary and secondary pumps.
Yeah, good point. That's usually where I see it on kind of larger, more complex, non-residential type systems. Next question: what should we do when the equipment, whatever the equipment is, water heater, pumps, tank, boiler, has no nameplate or the manufacturer is no longer in business? This goes back to the default table, vintage table issue. Take a look in our handbook. Feel free to ask us. Google is your friend. Go ahead and search Title 24 vintage table, Title 24 default values, and you will find some guidance on what we use for these numbers, and just base it off of the best professional judgment that you can get on when that system was installed. There was a question about EnergyPro versus CBEC Res. I just want to let everybody know that all of this information is specifically and only for EnergyPro version 5. The multifamily upgrade program is only working off of EnergyPro version 5. So the changes to the engine, the calculation engine that are driven by CBEC Res are not under consideration. Next question is, and I'll send this one to you, Kyle, can we do a power draw on existing pumps and use this to estimate the actual brake horsepower?
Yeah, I mean, if you can document it and you're getting the right power draw of the operating conditions, I think that's something hard to do unless, you know, the building is operating and you maybe trend that information for over a course of a good amount of period, you know, to figure out what that brake horsepower is. Doing it a one-time deal when you get out on the job site or the building and you do it just once and say, here, this is what the brake horsepower is, that's probably not very accurate because you don't know what kind of conditions that pump's operating at. You know, if you can't get a brake horsepower and you need to do a draw, then, you know, tell the maintenance guy that you're going to be leaving some equipment there for a week to find out what the operating conditions are of that pump. And obviously, just like everything else, document it, photo, you know, write it up, make sure your program administrators are on board with how you're capturing that information. But I wouldn't recommend just doing it a one-time draw and assuming that's the brake horsepower of the equipment.
Yeah, it kind of depends on what purpose you're using that for. I mean, for the purposes of our program, we're fine with you making a professional judgment on what the horsepower is based on the size of the pump, as well as just your professional judgment on what kinds of pumps, what kinds of sizes of pumps are typically put into domestic hot water service in these sizes of buildings. This is another question that speaks more to non-residential larger systems where the pump power can really balloon. So it depends on what you're using it for. If we're talking just, you know, little recirc, Brumfitt pumps that you typically see in the buildings, feel free to use professional judgment or give us a call and we can work it out with you on what the brake horsepower should be for that system. Can you explain why the program is still using EnergyPro 5 rather than EnergyPro 6? Yes, I can. It is a policy decision. When we launched the program, it was unclear what the status was of EnergyPro 6 adopting the new CBEC Res standards. When we launched the program, the CBEC Res engine was calculating domestic hot water inconsistently, and as a result, we needed to launch with something that was tried and tested, so we're sticking with EnergyPro 5. We are going to merge or migrate towards EnergyPro 6, and that will likely happen in the 2016 version of this program. There's a question about solar hot water. So it would be good, Kyle, if you could bring up EnergyPro again and talk a little bit about how you would model solar hot water. While he's doing that, I will say that the program does not allow you to take credit for a solar hot water system as an improvement. However, if you go to a building and you find a solar hot water system existing on site, we would like you to model that because you're trying to capture as accurately as possible the existing condition of the building. So if you do find a solar hot water system and you do have some information about it and it is still in service, Kyle's going to show you where you would grab that information and how you would model it.
Yeah, so to grab the information, you're going to want to use, there's a CEC solar thermal F-chart calculation, and in domestic or under the renewables tab, you can do that F-chart calculation, and you can get that from the CEC website. Download it. There's going to be some inputs on what type of system you have found out there. If it's old systems that you see, it might be hard to find the equipment, on that website because it's fairly new. But yeah, you basically need to get an F-chart calculation completed, which is going to give you what the net solar fraction offset is, and you can plug that number in here. F-chart's going to say it's 30% solar thermal offset. Then you plug in 30% here. And that will take it directly off your domestic hot water.
Perfect. Thank you. Still some more questions. So thank you all for being so active with your questions. When you have boilers with separate storage tanks, what input values go to the boilers and what goes to the tank? So if you look in the domestic hot water tab, you can model the system. You would model the boiler system basically is the answer to this question. So you would assign the recovery efficiency and the standby loss to the boiler system, considering it as one system. You wouldn't create a separate tank storage system specifically for that scenario. Do you agree with that, Kyle?
Yeah, I mean, I think your volume does make an impact on it. So if your storage tank, separate storage tank, I would suggest having that gallons representative in the volume area. And then, if it's obviously if it's a large system serving multiple buildings, you want to split that up, and you want to have that gallons adjusted over here. But gallons does make an effect on those larger systems. But you don't need to make two separate systems. You can actually, to be honest. So you can only, there's only room for one. So.
Great, thank you. So another question about savings relative to Title 24. This is a retrofit program, and the savings are site savings on a % improvement basis over existing conditions. So we're using EnergyPro 5, as I said before, because there was confusion over the consistency of values being reported by CBEC Res engine when we launched the program, and the savings that we're capturing are relative to the existing conditions of the building, and that is why the raters, the partner raters of this program, have such a key role, because we're relying on you and your professional experience to document the existing conditions accurately and completely. There was a question about CMSNH. CMSNH is the California Multifamily New Homes Program, which is also run by TRC. These are completely separate programs with separate decision makers and CPUC regulatory body oversight. So CMSNH decisions do not really affect our program's decisions, and suffice to say that them's the rules is what we're talking about. There's a suggestion from a rater to never model a combined space heat and domestic hot water system on the boiler tab. Thank you for that feedback. Yes, if you have a system that is combined hydronic and domestic hot water, you should create it as if it's a domestic hot water unit, and then later on you can specify that the domestic hot water boiler provides heat, and we will be talking more in depth about that during the HVAC trainings upcoming. So this is a question for you, Kyle. We've got a guy who's a little confused. If we input the standby loss, do we still input the energy factor?
You're not going to have an energy factor that comes up. So you have a recovery efficiency and standby loss. So energy factor, if you remember back to this slide, that was talking about greater than or less than 75,000 BTUs. Energy factor is for smaller capacity boilers, and the standby loss calculation is integral to the energy factor number you get. I mean, I can, if I just make this, 40,000 BTUs, then you'll see how the standby loss now is going away. It's less than 75,000. So 75,001 brings the standby loss calculation back in. Hopefully that'll clear that up. It's basically that 75,000 BTU threshold, equal to or less than, greater than, that kind of thing.
Yep, perfect. That was great. Thank you for showing it like that. I think that cleared it up. And I think this is going to be our last question. So if you have a complex that has 14 units and one large 100-gallon hot water heater, would you model it as different buildings with boilers? It's a little unclear from your question about whether or not you're saying this complex has 14 buildings with one large system, or if there's one building with 14 units. When you split out a system, you're splitting it out between multiple buildings. If it's just one building with 14 units, you would model the building as it stands with one domestic hot water system inside of it. If you have more questions specifically about this issue, you can feel free to contact me or any one of us here at TRC, and we can work with you on your specific project. The spreadsheet that Kyle was showing before was really for projects that have one domestic hot water system serving more than one building. In that instance, you would have to split up the efficiencies and the sizing of the system accordingly. But like I said, if you have more questions about your specific scenario, please contact any one of us here at TRC. I'm going to give it another half a minute in case anybody has any follow-up questions they want to ask. While I do, I just want to say thanks, Kyle. That was really great. And look forward to giving you all continuing education credits. So please send me your BPI number, and we can make sure that you get the credits. And we are recording this webinar, and we will be providing this webinar on our website. We have a Multifamily Upgrade Program YouTube page where all of our webinars are going to be available. So you can watch these and refer to these at a later time. I'll try and get this uploaded by the end of this week, but there's already some good content on there. So is there any other questions? Questions from the audience? It looks like no. So thanks a lot, Kyle. And if you
no worries,
have any
thank you very
words.
much.
Okay.
No, thank you very much, guys. I'll see you next round.
Great. So in 2 weeks, we'll be back for another tech topic. Thank you, everyone.